Hello everyone. Today we are going to fit a binomial distribution and test the goodness of fit. So suppose we have a data, or you can say xi, which is given is 0, 1, 2, 3 up to 8 and the corresponding frequencies, right? So the thing we have to do first is we have to calculate the mean. So for mean we'll find the fi into xi. Okay, so for that write the syntax equals to xi multiplied by fi. Okay, and press enter. Now click on the cell and drag it down up to the last ci or xi. We can get all the fi xis. Okay, now we will add them up. So for adding we will click on the auto sum option and select the number range. Okay, and press enter. So here you can see the total is 404. Also, not only this, we have to calculate the sum of these frequencies also. So for that, the same equals to, then select the range and press enter. So the total frequency sum of all the frequencies is 100. Now we will calculate the mean. Mean equals to summation fi xi. This is summation fi xi. Okay, divided by n, capital N, which is frequency. Then press enter. So we have got the mean here. Now we have to find the variance. So for variance we have to calculate xi square, okay, and then fi into xi square, or you can do it directly fi xi square, but I will break it down and go through step by step. So for fi xi square, put equals to, then click on the cell, then close the bracket, to the power 2. So 0 to the power 0 is 0 obviously. Now drag it down up to last to get all fi xi squares. Here you can see. Now we will multiply the fi with xi square. Remember that xi square. Okay, so fi into xi square, this one, and press enter. Now similarly drag it down. So drag it down, and here you can see a dot appears. Okay, so put your cursor on the dot, and you can see after putting it the cursor will change from a bold plus to a plus. Okay, simple slim plus, you can say. Now drag double tap on that and drag it down to get all fi xi squares. Okay, now add them up. Similarly we have added previously here. Now the total the sum of all fi xi squared is 1836. Okay, now we'll calculate variance. So variance, we know the formula. The formula is 1 by n summation fi xi square minus x bar square. So the x bar is mean. Okay, so just follow how I am writing it. So put a bracket, summation fi xi square divided by n, bracket close, minus bracket, select the mean, bracket close, to the power 2, press enter. So the variance is 2.0384. okay, so as we are going to fit the binomial distribution, so we have to know the values of p and q. So for p, okay, before we're going to calculate p, just we have to just find the length, or how many observations we have. So to count it, just here I am going to I'm going to roughly count it. Okay, so equals to count, then select the range and press enter. The count will do the how many number of observations are there. Okay, it will calculate it and show it us. So press enter. Here you can see 9. So we have a total of 9 observations. Okay, so now we are going to calculate p. So for p equals to mean, that is 4.04 divided by 9. 9 means this one. You can manually put the 9, or you can select the cell also. Cell means here there where we can count, use the count syntax. I prefer this one because whenever just look at the value 0.448899. Okay, now the thing I've told you that use the cell where we counted it, because if someone told you to add another observation here, just like 9, okay, then the thing is your observation number will change from 9 to 10. Okay, and when it is 9 to 10, you can see this here probability also changes, because because we have used this cell, mean divided by this cell. Okay, now I undo it. Now we calculate q. Okay, so for q equals to syntax is equals to 1 minus probability. Okay, then press enter. So the q is 0.55111 and 1. Okay, now we rewrite the xi here also. So up till this part we have calculated the mean, variance, p and q. Okay, p and q mean, which are the parameters. Okay, now paste it here. Now I think everyone know the recurrence relation of binomial distribution. If you don't, then I am going to write it here. Just focus on that. N minus x. Okay, bracket close. Just write it like this. N minus x divided by x plus 1 bracket close, sorry, bracket close, then n open, p divided by q. Okay, so by following this formula we are going to find the recurrence relation. So now the first thing is equals to bracket, another bracket. Okay, so first n means this one, minus x means this one, then close the bracket. Now divided by again x plus 1 bracket close. Okay, now close yes, close another bracket, just put a multiply option. Now open another bracket and select p. Okay, divided by q. Okay, then close the bracket and press enter. Okay, here is a little syntax error, I think. Yes, just wait a minute. I have opened it here. This one is closed here. Yes. Okay, now select the cell and drag it down. Here you can see it is throwing an error because if you see this cell, if you click on this cell, then you can see that I have selected the mean p and q. Okay, but when we go to the another cell and look at the formula bar, then you can see that it is not selected, but we have to select. So for this we just have to do one thing, put the dollar sign here and here. This will make it constant. Okay, constant in the sense it will not now move to another cells also. If you drag it down, just see, press enter. Now drag it down up to the last cell and you can see the numbers or the recurrence relation numbers. Okay, so as you can see we have calculated the recurrence relation. Now we are moved to the find the probabilities. Okay, so first of all write probability, write the cell name. Okay, now we have to find the probability. As it is a binomial distribution, so we are going to use the binom.dist. Here you can see. Okay, now number s in the sense your first number xi, then comma total number of observations. So here total number of observation is 9, so I'm going to select this cell and then place comma and now probability means p. Okay, then comma, it is false. Okay, now press enter. False in the sense because it is not a probability density function, or you can say it is not a continuous distribution. Okay, so if the distribution is not continuous, we will select or write false here, and if it is continuous, then we will write it true. Now close the bracket and press enter. Okay, so this is the probability, but we have done a little mistake here. We have to write it like this, or like this, so that the cells should be fixed, because if the cell changes, then our value will not appear, and it will throw an error. Okay, so now enter. Now we can drag it down till the last xi. Okay, now we have to find the n into probability. Okay, just wait a second. Capital N into probability. Okay, so for that we have to multiply the number of frequency, total sum of frequency into probability. So write equal 100 into this one. Okay, now enter. Now drag it down. Here you can see it will throwing an error 0 0. It is not correct actually, because you can see it is the total cell is different, but we have to choose this one. So for that, same, put the dollar symbol and press enter. Now we can drag it down and we can get the result. Okay, so as it is the everything is on a decimal, so we have to get the expected value, which should be a fixed or a real natural numbers. Okay, or a whole number. Frequency, double tap here, it will take automatically its width. Now expected frequency means we have to round it up. Round, bracket, select the cell, bracket close. Okay, sorry, here we have to tell him what is the number of digits, okay, before or after decimal that we want. So we don't need any decimals. Okay, so enter 0 and then enter. Now drag it down till the last. So this is the expected frequencies. Okay, now we are going to test the goodness of fit. So for goodness of fit, just copy the observed frequencies, okay, here, and change the name to observe CIES frequencies. Okay, and the expected frequencies here. Okay, now we have to pull it. So pulling we do this pulling just because if the expected, okay, what happened, just a second, why it is showing 0? Oh, okay, because okay, got it. We have to select this one. Okay, so for that just change it to J, press enter. 0, then now drag it down. Okay, so we have to do pulling because if the expected frequency is less than 5, okay, then we have to add it with his neighbor expected frequency, just like this. Here you can see 0 and 3 both are less than 5. So first of all we add both of them, and so for margin center, then just equals to, so first of all we add them up, add the two expected frequencies, this one plus this one. Okay, now you can see it is throwing it returns 3, which is also less than 5. So that means we have to add the first 3. until we got the number which is greater than 5, we have to add them. Okay, so for that, margin center, now just change it to H2 and O8. Okay, now you can see this it returns 14 which is obviously greater than 4. So now here we have added 3 expected frequencies, so we have to add 3 observed frequencies. Okay, remember, because before pulling, or whenever you are going to pull, just first of all pull the expected frequency and then pull the observed frequencies. Okay, now sum bracket, select 3 cells of the observed frequency, now press enter. Okay, which is also greater than 4, ignore it. Okay, now you can see that the expected frequency from below. Okay, select the 3 cell, then sorry, then margin center, now equals to sum, select the 3 cell, close the bracket, press enter. Okay, it is returning 17, which is obviously greater than 5. So similarly we have to pull three observed frequency from the bottom. Okay, this one. So margin center, then equals to sum, select the 3 cell, close the bracket, press enter. It is returning 14, which is greater than 5. Okay, now we will put the formula of goodness of fit. Observed minus expected whole square, sorry I forgot to put the bracket, whole square divided by expected. Okay, so first 3 cells, margin center, because we have pulled these 3 cells, so for that select the observed one. Okay, first put a bracket. Okay, now select the observed one, pulled observed one, minus expected, okay, whole square divided by expected. Okay, then press enter. It will return 0. Then equals to, select the, here you can see 20 is greater than 5, so we haven't pulled it. Okay, so put a bracket, select the observed minus expected, close the bracket, to the power 2 divided by expected. Okay, press enter. Now drag it down till this much, because after this after the 21, 12, 4 and 3 are pulled. Okay, so for pulled, similarly margin center, then equals to observed minus, put a bracket first, observed minus expected whole square divided by expected, oh sorry, divided by expected. Okay, press enter. 0.529. Okay, now we have to add them up. So for adding means we have chi-square calculated, chi-square calculated. When we add these ones, we will get the value of chi-square calculated. Okay, so for this, click on auto sum option, select the range, then press enter. It is 1.11366,085. Okay, now we have to find the chi-square tabulated. That means we have to find the tabulated value of chi-square. So to get the tabulated value of chi-square, we will use the formula chi-square dot inv dot rt, and probability is 0.05. That means 5% level of significance, and the degree of freedom is 2. Now here's the question. There are 9 observations are there, and we know if there are 9 observations, then the degrees of freedom should be 8, but here I am writing it is 2. So the 2 is because we have pulled them now. So here you can see the 2 and sorry 3, first 3 and the last 3 observations are pulled. So total there are 9 observation. Okay, and we have pulled 6 observations. That means 9 minus 6 is 3. Okay, and 3 then minus 1, 3 minus 1 is 2, so the degrees of freedom is 2. Okay, and I'll write it here, the formula. Now we will draw the conclusion. So for conclusion, we use the syntax if equals to if, then the logical test. Logical test means calculated value of chi-square. If calculated value of chi-square is less than tabulated value of chi-square, comma, accept the null hypothesis, otherwise reject the null hypothesis. Here the null hypothesis is the distribution is binomial distribution. Okay, so now press enter and it accepted. That means the distribution is fitted. Okay, so this much. I hope you understand the whole process, how we fit a distribution, obviously how we fit a binomial distribution and test the goodness of fit. Okay, thank you so much.